In 1997, a machine beat a human world chess champion, shifting our understanding of what computers could do. Today, instead of moving chess pieces, the machine is writing thousands of lines of production-grade code, flowing across a screen in seconds. For centuries, technology focused on mechanizing physical muscle. Now we are mechanizing complex cognitive reasoning at an industrial scale. This chart shows the projected impact on the global workforce by 2030, according to the World Economic Forum. While 92 million traditional jobs are slated for elimination, an estimated 170 million new roles are actively being created. But those new opportunities are not evenly distributed. The labor market is actively splitting into a two-track system. On one side, roles are democratized, allowing novices to easily perform previously complex tasks. On the other, roles are hyper-professionalized, where artificial intelligence acts as a massive force multiplier for deep subject matter experts. International Monetary Fund Managing Director Kristalina Georgieva recently described this transition as a tsunami hitting the labor market. The IMF calculates that 60% of all jobs in advanced economies will be profoundly affected, either enhanced or eliminated, in the next few years. These warnings, delivered at the World Economic Forum in Davos, signal a structural realignment of the global market, already in motion. The data suggests a market where individual AI fluency, rather than the machine itself, has become the primary driver of professional displacement. The technology has quickly evolved past basic predictive text. We are entering the era of agentic workflows, systems capable of autonomous planning, iterative reasoning, and multi-step execution with minimal human intervention. Because localized systems can now handle routine data entry, call center operations, and payroll processing, the traditional offshore outsourcing model is facing rapid disruption in global hubs like Visakhapatnam. Tasks that are easily eliminated by generative models are precisely the entry-level duties young people traditionally use to gain corporate experience. Economists at institutions like Stanford note that this is driving a seniorization of the entry level, disproportionately affecting youth employment. As these routine tasks are absorbed by automated workflows, the window for learning on the job is closing. Graduates are now expected to contribute architectural thinking and strategic value starting on day one. This line graph illustrates the financial reality of early adoption. Workers demonstrating specific technical literacy currently command a 62% higher average salary than their peers across all sectors. Organizations are desperate for professionals who can actually deploy and govern these systems in a production environment. This drives massive demand for applied AI engineers, machine learning operations specialists, and AI ethics leads. As nations enforce strict data privacy laws, countries like Singapore are investing hundreds of millions into localized, sovereign AI compute hubs, requiring experts to navigate fragmented international regulations and copyright compliance. Yet the digital promises of this technology are strictly bound by immutable physical constraints. Training and running autonomous agents requires gigawatt-scale data centers, ultra-low latency fiber optic networks, and massive thermal management systems. To support this sheer volume of computing power, major technology firms are making historic investments in physical infrastructure, such as Google's $15 billion gigawatt-scale AI hub in Visakhapatnam. Building these massive facilities has triggered an unprecedented hiring surge for skilled trades. Demand for electricians has jumped. Hiring for HVAC technicians is up 200%, and postings for robotics technicians have skyrocketed by 500%. The massive virtual computing requirements are pulling wealth out of pure software and driving a historic transfer of capital directly into the highly skilled physical trades. The anxiety paralyzing the current workforce is largely driven by the lump of labor fallacy, the static assumption that there is a fixed, finite amount of work in the world, and if a machine does it, a human must inherently be unemployed. We've already seen what happens when companies ignore human oversight. The recent software engineering crisis, where firms hastily replaced developers with generative models, resulted in massive volumes of functional but structurally chaotic code. It created an unsustainable mountain of technical debt. As technology masters the logistics of technical reasoning, the economic value of biological and emotional skills increases proportionally. Microsoft CEO Satya Nadella has warned that the industry risks losing its social permission to consume vast amounts of energy, if the technology fails to generate broad societal benefits. Companies are shifting from merely deploying tools to re-architecting the firm as a learning system centered on human agency. Foundational technical literacy, understanding Python, cloud infrastructure, and vector databases, is the mandatory starting point. But the skills that will actually protect a career over the next decade are ethical judgment, complex problem framing, and team leadership. An algorithm can flawlessly predict statistical tokens. It cannot read subtle interpersonal cues, navigate office dynamics, or build genuine human trust. Those human capabilities are the ultimate career moat. To secure a competitive advantage, students must take highly specific educational pathways. Computer science majors need to push past the abstraction layer of consumer chatbots and focus on building production-grade systems, mastering deep neural networks, PyTorch, and retrieval-augmented generation pipelines. Engineering students in traditional physical disciplines should focus on applied artificial intelligence. The goal is combining traditional infrastructure design with predictive analytics, spatial reasoning, and industrial sensor data. Business and humanities students must become workflow architects. They need to understand exactly how to drive revenue and reduce friction by mastering prompt chaining and integrating API platforms. This technology lowers the barrier to entry for highly specialized roles. Researchers and economists at MIT point out that these systems allow less experienced professionals to perform at higher levels much sooner, effectively compressing the traditional learning curve. Because employers expect immediate strategic value, the traditional paper resume is no longer sufficient. Graduates must build verifiable public portfolios, like a GitHub repository of end-to-end projects, or a detailed breakdown of an automated business workflow. Formal education is no longer a finite event that ends at graduation. Career survival requires treating your skill set as a continuous, lifelong operating system update. By 2035, the modern professional will not execute manual, unbundled tasks. Instead, they will act as a maestro, conducting a symphony of autonomous software agents. The daily corporate focus will shift away from basic data processing. The premium will be placed entirely on high-level strategy, client empathy, and creative problem-solving. Relieving humans of the infinite scale of digital execution leaves us entirely free to dictate the direction of our ambition.